Okay. Good evening, everyone.
Good evening, everyone.
Hey, Mr. Hoyer, can I ask you a question?
Hello. Good
We don't got
evening.
cla-
How you
we
guys
don't got
doing?
class on Fridays, huh?
Good
We
evening.
don't have class on
Okay.
Friday.
It seems like someone has the microphone open.
Yeah, it's me, Tatiana. I'm asking you a question, Mr. Hoyer.
Oh, I thought you were talking somewhere else. Go ahead. I couldn't understand. I thought
Uh-uh.
it was far away. How
It's
you
no
doing?
school. It's no school on Fridays, right?
No classes on Fridays. No.
Okay, I'm just asking because I still get like an email. I was only asking. Thank you.
Yeah, no problem. This is fixed with the school director. Remember that I told you when we were in the presential classes that I was going to remove Fridays?
Yeah.
Yeah, because it's too much. Well, too
Okay.
much for you, too much for me too. So it's a lot because I work on Saturdays and sometimes on Sundays. So that will be just too much.
Oh,
No, everything is okay. We're gonna cover everything during the time frame Monday to Thursday, so nothing is gonna be left behind. Okay.
okay.
All right, guys. So good evening again. So we're gonna continue with the integumentary system once again. Pay attention to the cues that I give you, the advice that I give you about certain things that you need to know for the exam. Most of the other things are kind of basic general knowledge. Whether you're gonna need it or not, for the exam, I'm gonna give you all the information that you need for that. Anything else is just, once again, general knowledge. It is important that we have an idea of the functions of all the systems of our body. That's basically what it is. That's what we cover all these chapters. Because when the patient comes into your office complaining about something about the skin, you can understand. You have an idea. You can ask questions, or you can kind of explain the patient something that the patient probably doesn't understand after the patient sees the doctor. Remember, the patient feels more comfortable talking to you versus talking to the doctor. So they don't ask questions to the doctor. They come to see the doctor and the doctor tells them, do you have any questions? Did you understand what I just told you? Oh, yeah. Or they just move and nod the head, saying yes. And when they come to the waiting area or to the front desk, they start asking you questions. Oh, the doctor said something about something, but I'm not pretty sure. So sometimes we have to reinforce that information. But if we don't have a clue of what anatomy and physiology is all about, if it doesn't regardless to that the question, same we're not gonna know how to address the situation. Most of the things, remember, you do not explain the patient things that you do not know or things that are not asked. So you only address things that the doctor has discussed with them and they are not pretty sure about it, like following instructions, like scheduling appointments, things like that. But when it comes to diagnosis, explanations, and things like that, or medications, you refer them back to the doctor. Let me see if the doctor is available. You go to the doctor and you tell them, Mr. or Mrs. Smith is asking you a question. Do you want to see them? Do you want to talk to them again? Because that's what happens most of the time. So we don't get involved. Remember, we just kind of the liaison in between the doctor and the patient, like the bridge in between them. But it's important to know certain things. At least you know what is it that the patient is talking about so you can relay this information to the doctor. Other than that, you're going to be kind of lost. You read something on the medical record and you have no clue. That doesn't look good. So at least you have an idea. Okay, so last night we were talking about the functions of the skin. Remember, the functions of the skin are very important. Not only the skin, from all the systems. Very important that we know the functions, some of the major functions. So let's recap some of the functions. It is a protective covering. Remember, this is a layer. This is the largest organ by weight of our body. So everything that kind of wants to get inside our body, they hit this wall, which is the skin first. So that's basically what it is. Anything, a mosquito bite, something flowing or something that hit us, or just a fall, is gonna hit the skin first. So the skin is gonna be injured, not the internal organs. Well, all depends the type of injury, right? A bullet is gonna go through everything. But we're not talking about that. We're talking about these external environmental issues, microorganisms, the weather, things like that. So that's basically what it is. Prevents water loss. We talk about that. Remember, this is like a bottle, the plastic bottle, that it protects the liquid inside. So there are lots of liquids within the tissue, within the muscles. So if we didn't have the skin, then this liquid could easily leave our body. Same goes for liquids outside. Liquids outside, let's say we're walking under the rain. That water is not going to be absorbed by our body. It is going to be repelled by our body. Yes, we're going to get soaking wet, but that's it. This water is not going to enter our body. Likewise, if you swim in a pool, in a lake, in the river, in the ocean, this water is not going to go inside. So those are some of the major functions of our skin. Now, it contains sensory receptors. So we sense something. We feel when somebody touches us. We feel pain. We feel temperature, whether it's cold or it's hot. So very, very important. Helps to produce vitamin D. So remember, this is one of the questions for exam. What is the major function of the skin besides protection and all the stuff? But it's not going to talk about that. It's going to say, oh, vitamin production. Actually, it's going to tell you that it's vitamin production, but it's not. The skin does not produce vitamin D. It helps to produce vitamin D, which helps to produce calcium or to distribute calcium in our entire body. Remember, we talk about how the skin regulates temperature. If it is cold, then all these liquids can stay inside and the pores are going to close. That's why we develop these goosebumps when we are cold. And if it is hot, then some fluids are going to be released as a way, as a form of sweat to cool down the skin so we can protect the internal organs. And when it's cold, same. We're going to protect our internal organs. Remember, if we expose ourselves to long periods of time within any type of weather, whether it's hot, whether it's cold, well, our body is going to collapse. But the skin protects us for that. Well, it's not going to happen, but well, at least it gives us some time for us to take measurements to protect ourselves. If it is cold, well, We put something on, or we get inside a place. So that's how we're going to protect ourselves. So that will be most of the functions of the skin. Okay, moving on. Remember, if you have a question, just please ask me. Problems in temperature regulation. So we just talked about the skin being a temperature regulator, right? But sometimes, because we have been exposed to long periods of time to the weather, if it is cold, we are going to develop something that is, if it is hot, we're going to develop something that is called hyperthermia. Remember, hyper means an increase, thermia means temperature. So high temperature. This is a normal body temperature inside because we have been exposed to long periods of heat outside or inside something that is very hot. It says right here, can occur on hot or humid day. How do we know? Well, it's very easy to know if we are hot, but how do we know that we are reaching the breaking point? Well, our skin is going to become dry. The person is going to become very weak, dizzy, is going to develop nausea, headaches. The pulse is going to be very rapid, and eventually the patient can collapse. So once again, that's how the body is, particularly the skin, is going to try to regulate this temperature. But when you are exposed to long periods of time under these high temperatures, well, there is nothing that can help you if you have not been removed from that place or you are not hydrating yourself. So all this will be the signs of someone who has been exposed to high temperatures. So the key here is to know what is hyperthermia. So hyperthermia is nothing else than high body temperature. Remember, your body temperature inside is different from the temperature outside. The environmental temperature is one thing. Inside our body, we have a different temperature. So if it is too hot outside, well, inside, our organs are going to develop this high temperature, which is not good, which make all these changes. So that's basically what it is. The opposite is also true. Hypothermia. Hypo means below, low, or under is a normally low body temperature. Now we are too cold. Remember, we don't notice that it is our organs inside that are cold. We just feel the outside and we start shivering and we look for something to cover ourselves. So once again, prolonged exposure to cold or you're sick because there are some conditions that makes your body temperature becomes cold. There are some conditions that make your body to feel hot, like fever, infections. Cold is the same. So one of the first symptoms that you feel is shivering. This is when your muscles, remember these involuntary skeletal muscles, start contracting, start spasming. So some spasms start occurring there. And that is because there are some problems with this control center of temperature. So that is basically what it is. Eventually, if this is not treated, what's going to happen to this patient? This patient is going to feel confused. Then it's going to fall into lethargy. It can lose all the reflexes. It can collapse. So it can become unconscious. So whether it's high or low temperature, and if we are exposed for long periods of time to these type of temperatures, our body is going to collapse. Eventually, if it's not treated. So hyper and hypothermia, those are the problems with that affects mainly the skin, remember, because it's the first barrier of protection of our body. Everything starts from there. So when this barrier cannot cope protecting our body, then internal organs are going to start feeling cold. And then it's when we are going to start presenting with all these signs and symptoms. See, any questions about hyper and hypothermia? Remember, temperature. This is important. I mean, everything is important, but this is important for your exam. So that's basically what I'm trying to tell you. Let's talk about burns. Burns are of three types, 3 degrees. So I'm going to tell you how you know if this patient has a 1st-degree burn, 2nd-degree, or a 3rd-degree. It is very important because there are certain cues, certain keywords that are going to help you to distinguish, to differentiate this type of burns. If you don't follow these keywords, guess what? You're gonna mix it up. You're gonna select the wrong question. So think about this. It's telling you 1st-degree, 2nd-degree, 3rd-degree. So there are 2 things that you have to take in consideration. So let's go back to the layers of the skin. How many layers the skin has? 3. Well, right there I have the answer, the first answer for your questions. 1st-degree, if the first layer of the skin is involved, is a 1st-degree burn. Easy. 2nd-degree, if the 1st and the 2nd layers of the skin are involved with the burn, 2nd-degree burn. Wow, can't be any easier. 3rd-degree, all the layers of the skin are involved. Easy, right? Very easy. So it says right here on the first one. Now we're going to go over this. 1st-degree injures only the epidermis. What is the epidermis? The first layer of the skin. Because that's 1st-degree. Only the first layer. The outer layer is being injured. Now, how do we know that is 1st-degree? Because the only thing that we're going to see in all over our skin is redness. Our skin is going to become red. Yeah, we can have some type of inflammation. Sometimes we don't even notice. But the redness. So the first layer of the skin is being involved, and How do we know? Well, we cannot know if it is the first layer, but we're going to see redness. So the question is as follows, or maybe more than one question. What type of burn involves the epidermis? Oh, first degree, because I know epidermis is the first layer of the skin. What type of degree, of burn degree, does the skin turns red? Oh, wait a minute. That is first degree. So that's it. I'm done. What will be some of the samples of this? Sunburn. You know, when you expose yourself to the sun, you go to the beach, by the pool, by the river, lake, whatever you want to do, you expose yourself, or you're doing some backyard, front yard work, and you do not protect yourself. Then guess what? Your skin is going to turn red. That is first degree. That is it. So first degree, the first layer of the skin. How do we know? Because the skin turns red. That's it. Second degree. It says right here, damage. Well, let's be a little nicer. Not that destroys, let's damage the epidermis and the dermis. 2 layers. Doesn't was number 2. Now, how do you know that this is second degree and not the first degree? Very easy. Because you're gonna see blisters. Blisters. If you see blisters after you burn yourself or your patient burns themselves, this is a second degree burn. Very simple. I'm telling you. You don't need to go through every single word in your book because it's going to tell you a lot of things that is going to be distracting you. So first degree, only the first layer of the skin, which is the epidermis. That's why you need to know the names of the layers of the skin. Since I don't know, I see redness, it can be a second degree. Why? Because second degree, also the skin becomes red because you have a burn. But then you can have blisters. So that is the key that differentiates first degree from second degree. Both skins are going to be red. Maybe they're going to have some inflammation. But guess what? Of course, you're going to have pain there. It burns, the burning sensation of the skin. But one is only red. The other one have blisters besides being red. But remember, second degree burns the first layer, the epidermis, which makes the skin become red. But now, because it went down deeper, now you're going to have blisters. So that's basically what it is. Remember, those blisters is something that you shouldn't be playing with them. You should not be popping those blisters, breaking those blisters, because what happens is this is the liquids. These are the fluids from inside our body that forms there trying to cool down the burn, just like when we sweat when it's hot. That's the mechanism of defense. But guess what? If you break them down, so what's going to happen? Not only you're not going to be protected, but infection is going to go there because now you make an entrance right there. You poke on those blisters. Now you have a point of entry. Microorganisms can enter there. So instead of doing better, you make it worse. So this second degree is very painful, very painful. It's the most painful of all three. And I'm going to tell you why. So let's move to third degree so you can understand. So third degree involves the three layers: epidermis, dermis, and the fat tissue. So here, your skin is completely destroyed. Your skin is charred. This is the worst burn because this can kill you. Or the area that is burned, that's it. That tissue there will never regenerate if you happen to survive. Because the three layers of the skin have been involved. Think about the dermis being involved. And what is it that the dermis contains? All these accessory organs. Sweat glands are destroyed, damaged. The oil glands are damaged. The hair follicles are damaged. The nerves are damaged. The blood vessels are damaged. So everything is damaged. So you destroy that part of the skin. This is the worst one, but it's not the most painful because everything is dead. When everything is dead, you don't feel anything. You feel it when you have invasion to the first layer or to the first and the second. But the second is the worst because of the blisters, because it has invaded the second layer, which is when we have the nerves. The nerves are in the second layer. They've been affected. And the nerves are the ones that cause us pain. Now, third degree, that everything is burned, is damaged completely. So you're not going to have no pain because the nerves have been destroyed. So that's how you are going to identify this type of burns, remember. And these are questions for exam, particularly second degree, because they're going to tell you the patient presents, okay, you have a 45, 50, 12 years old person presents to the office complaining about burn. When the doctor examines the patient, see blisters. Oh, wait a minute, blisters, second degree. Or the patient, when examining the patient, the doctor sees redness of the skin. What layer is being involved? The epidermis. What degree is this type of burn? First degree. That's how you need to remember this. That's what I give you, very summarized information, and I explain it to you so you are able to understand exactly how to differentiate these type of burns. Otherwise, they sound like most of them, because all of them are going to have a redness, swelling, pain, this, that. No worries. That's not the key. The key is only redness, nothing else mentioned. They're not mentioning blisters. So redness, first degree, epidermis is involved. Blisters, redness, swelling, this and that, no problem. Blister is the key. And they're going to mention the blisters because that's the key word. So then you know that this is second degree. All the layers of the skin have been involved. That's the third degree. If they happen to ask you, I haven't heard about this, but you never know, which of the following burns is the most painful? Second degree, not third degree. Remember, you think third degree is the most painful. No, it's the worst. But it's not painful because everything is there. And when you're dead, you're not feeling anything. Any questions about this type of burns? Remember, I want you to remember this. And you're gonna have your information right there, so you can use it as a reference. Okay. So no questions. So we're done with this chapter. We're gonna move to the nervous system now. Today, I email you some of the chapters that I, for some reason, didn't go through, because I believe that these messages of these attachments were kind of large and they didn't allow to pass all the chapters. So sometimes I divide them, but this time, for some reason, they didn't go through. So then I realized it and I fixed the problem. So I send it back to you. So you have the rest of the chapters. So this will be the nervous system. So we're gonna have 3 chapters, short chapters, because we divide them in nervous system 1, nervous system 2, and the nervous system 3. We're gonna make it as simple as possible. The nervous system is very complicated. So once again, we're gonna cover them. I'm gonna give you explanations, details, but I will also mention the things that you need to know for the exam, for my exam, for the national certification. So what is the nervous system? Well, once again, let's talk about the nervous system. So this is a control center of our body. Let's put it that way. So the nervous system is like this electrical wiring inside our home or our apartment. So it's gonna pick up the electrical impulses from the transformer outside to the meter that is close to our area or in front of our home or by, I don't know, somewhere in your building. And then we're gonna put some cables down, some wires that is gonna be distributed inside the walls of your home or apartment. So it's gonna take electrical impulses back and forth. That's basically what it is. So with the nervous systems is something very similar. The nervous system picks up stimulus from the outside, from the environment. Think about if it is hot, how do we know that it's hot? Because we have some receptors, the thermoreceptors, the temperature receptors that we have on our skin. So if it is too hot, the heat we receive this heat on our skin, or if it is cold, and these receptors of heat or cold are going to bring this information to the brain through all the nerves of the skin, to the spinal cord, to the brain. There is a part of the brain that is going to interpret this information. Immediately, your brain is going to tell you to do something. The first thing that the brain is going to tell you, if it is cold, it says, I'm going to chop down all the systems on your skin. So your skin becomes tougher. And that's what you start shivering. That's what you develop these goosebumps. I mean, again, that's how our body protects ourselves. See, the brain tells you, but tells who? Tells the skin to do something to protect you from cold. If it is hot, the same way. These heat receptors receives the heat, is too much for the skin sends this message to all the nerves of the skin, to the muscles, to the spinal cord, to the brain. The brain is going to make a decision. Oh, what am I going to do to protect my body from the heat? Then it opens up the pores and allows the fluids to go out. That is sweat. So that fluid can cool down our skin. We have mentioned that several times. I have. So that's a way of protecting. See, the body itself tries to protect whatever happens. If it is outside, let's say that it is inside our body. I'm eating lots of sugars. Well, when the sugar enters the bloodstream, then immediately we're going to have some receptors, some hormones that are going to detect this excess of glucose or cholesterol or sodium or potassium, magnesium, every excess of water. Immediately the brain is going to command, is going to send the information to one of these glands and send the information through the nervous system to activate the pancreas for sugar. It says, hey, pancreas, wake up. We need insulin. Produce more insulin right now because there's lots of sugar right there. So insulin is secreted in large quantities. And insulin is going to be going to the blood flow and capture every single glucose. And it says, hey, you can be here. We're going to remove you. And they're going to store this glucose somewhere else. But enough is enough, right? They do certain work. But if you're putting too much, they can't do the work. This is like you working by yourself in a company, in a factory, producing and moving and doing. That's impossible. So that's basically what the nervous system does. Whenever something increases in our body, the nervous system sends some signals to this particular organ to release certain enzymes, to release certain hormones, to level whatever is being produced in excess, whatever has been consumed during the diet as an excess of something. That's how it happens. We know the pain receptors. We have pain receptors on our skin. So whenever we feel pain, immediately these signals are sent through the nerves, through the spinal cord, to the brain, and the brain is going to determine what's going on, what to do. That's the nervous system. It gathers information, store that information, and then try to control, send signals to these particular organs that are being affected and try to correct the problem. That's basically what it is. It's like when you come and complain about something to the police department. That's like the nervous system. Something is going on, something happens to me, somebody vandalized my car, my house, stole my wallet, they harassing me, they hit me, they beat me, whatever the case may be. And then the police has got to do something, right? Look for the perpetrator. That's how it works. The nervous system does all these things. It controls everything that happens in our body, in and out. Because we feel something from the outside, from the environment. Think about this. I'm talking to you right now, and I'm far away from you guys. I'm not even close to you. Even if I'm close to you, I'm not speaking directly inside your ears. Well, the nervous system does so. It takes all these sounds and transport it to the system, and you hear my voice, and you kind of translate all this information that I'm giving you. All this goes through the senses. The same when you see something and you can describe that, because it goes to that image goes to your brain and is stored there. If it is the first time that you're seeing this or you're hearing about this, see, like now you're hearing for the first time about all these systems, functions, organs. Next time when someone asks you something, it's the nervous system who's going to retrieve that information and say, oh, I know that. I heard about that. I have seen that. That's the nervous system. We collect all the information, and it does send a response. Remember, if you go to the police and you complain about something, if the police doesn't do anything, then it was a waste of time. So then what do we have the police, right? They have to do something about the complaint that you made. The same with the nervous system. The nervous system captures all these environmental situations, all the internal situations, but it doesn't do anything about it. So what is the purpose of having the nervous system? I don't need someone who just come here to claim the salary, but you didn't work. That doesn't work that way. So the nervous system gathers information, stores that information, and then it gives a response to whatever information they gather. That is the key with the nervous system. So it's very important. It is a control center of our body. The brain and the spinal cord. Let's just start with talking about the smallest living organism, which is cell, that makes up the nervous system. The cell that makes up the nervous system is called the neuron. See, nervous neuron is the smallest living unit of the nervous system. Remember the cells that makes up the bones? Osteocytes. So they are the one who makes up the bones. But it's not the same that makes up the brain. No. The cells that makes up the nervous system is called the neuron. Nervous neuron. That's basically what it is. But these cells do not work by themselves. They need assistance. Think about this. The director of the school, the CEO of a company is just someone at the head of these organizations. But they have to have other people that they can relay information to it, delegate other tasks. So the neuron is the most important cell of the nervous system. But they are not the one who are doing everything. They have other cells that are the assistant cells, the supporting cells, and they are called neuroglia. Neuroglia. But usually, because these names are so hard to remember and to pronounce, we just use glia. Glia. Glia are supporting cells. Supporting who? The neurons. They support the neurons. So we have the main functional units of the nervous system, which are the neurons, but they have assistants as well. Remember, the neurons by themselves cannot do anything. The president and the vice president don't do everything. They give orders, but they have people who are going to, follow those orders. So those are the neurons. So if you ever been asked, what is the name of the cell that makes up the nervous system? The neuron. There's no way you're gonna get it wrong. Book. What is the name of the supporting cells of the neuron? Glia. If you don't see glia, then it says neuroglia. Glia, supporting cells. Who supports? The neurons. They work together. They work as part of the team. Any questions? Remember, I'm trying to summarize, I'm trying to make it as basic as possible, but without leaving anything off. It's the things that you need for your program. Knowledge that you need to get by with something that you have to do at work, but this is not something that you're going to be using at work. But it's part of the systems that we have to talk about. But I will point out every single term that you might encounter in your exam, because that's what really, really matters at this time. You're going to get some basic knowledge, yeah, but you need to get that knowledge for you to do well on your exam. So the neuron. Now let's talk about the neuron. What is it? Well, this is the cell, remember. The neurons are the functional structure units that makes up the nervous system. Well, they have parts. They have certain structures, and each part of this neuron, they're gonna make different functions. Remember when we talk about the cell membrane, the cytoplasm, and the nucleus? Well, we have these three parts because each part has different functions. Well, this neuron is not an exception. We're gonna have three parts of the neuron. What is it that they do? How do we identify them? Very important. So let's look at the picture of a neuron. This is how the neuron looks like. These are the three parts. So this is the axon. See, all these part right here is the axon. This part right here is the cell body. And these branches right here, these are called the dendrites. So dendrites, the branches, the cell body is where the branches and the axon, it is attached to it. See? So let's go back to the lecture. Now you have an idea what is it that we are going to be talking about. So I'm going to be going back and forth. See, dendrites are known as branches. As soon as you hear the word branches of a neuron, immediately you know that these are the dendrites. That's it. So what is it? What is the main function of the dendrites? They conduct, they bring impulses to the cell body. So all the impulses that we carry on inside, the stimulus, they feel something, they feel pain, they feel excess or not enough something inside the body, they feel cold, everything. So this is the information that is gonna enter the cell body. Let's go back again. All the stimulus enters through here. All the stimulus, anything that is going on outside or inside our body enters through these branches. That is what it's telling you. They receive the stimulus and send it where? To the cell body right here. Why send it to the cell body? Because here is when we have the nucleus, the brain of the cell. And that is the one who's gonna decide what to do. Okay, it's too cold outside. All this stimulus of cold brought by those receptors are gonna enter right here, these signals. And the brain is gonna make a decision. It's gonna tell the body to do something. So these branches, once again, called dendrites, very important. The dendrites are branches. And what is the major function of these branches? They receive, they conduct the impulses, the signals inside the cell body. And what does the cell body contains? The nucleus. And the nucleus is the brain of the cell. So they are the one who's going to make a decision what to do with these impulses that enters the cell. That's basically what it is. So those will be the dendrites. Now, I already answered the cell body. Contains the nucleus, the cytoplasm, and the organelles, because that's what the cell is all about. What is it that is going to do? Well, it's the nucleus that is going to process the impulses or the signals that were brought through these branches. Then it's got to happen something because, once again, remember, you went to the prison to make a complaint about something. So you spoke to someone over there, they take notes. Now they cannot just leave those notes right there. They have to take action. They have to process that complaint. And now they're going to delegate someone to go and investigate what's going on. Well, the prison is the cell body. The dendrites are the people who complains about something and goes to the prison to file a complaint. Now, the person who took the information, the complaint, is going to delegate someone else to go investigate. That will be called an axon. So the axon conducts impulses away from the cell body. So this is the one now is sending the message. That's basically what it is. So now we are going to take action of what's really going on. So that's how this works. So it's not one cell. Remember, we have millions of neurons in our brain, spinal cord, and the peripheral nerves. So every signal, every command, every impulse that happens outside or inside the body enters the dendrite. The dendrite conducts them to the cell body directly to the nucleus. Now the nucleus is going to process that stimulus and is going to send an answer through the axon. But remember, I mentioned already there are millions of cells. So here we're going to have more dendrites, more dendrites, more dendrites, a cell body, and another axon. Here, more dendrites, more dendrites. So we're going to have a chain of cells. They are connected like links. And these cells go to the skin, to the organs, to the eyes, to the heart, to the liver, to the intestines, everywhere. That's how it works. This is a network. inside our body. Think about all these cables inside the walls for the electrical cables. So it's the same. That's how our body functions. How our body is going to regulate, who's going to tell them the information? Well, the organ that is failing, when something is kind of decreasing, when the balance is being lost inside our body with all the chemicals, hormones, nutrients, the body has to make a decision. But these organs are telling these same signals because this organ is not functioning normally. So immediately send the signals to the brain, and the brain tries to correct these problems. That's how our body functions. And that's how the system outside our world, the justice system, the health system, the educational system, all this system, security system, immigration system, you can call it any system, that's how they work. We hear about problem, we hear about the Hurricane Helene, immediately somebody has to be responsible to answer, to help, to assist that particular state, that particular town. So that's exactly what happened to the nervous system. It's a network. Everything that is going on inside and outside on our body that is captured by our receptors is going to have an impact. It's going to have to be translated. It's going to go to the brain. The brain is going to analyze what's going on. It's going to see who's responsible, who is going to take charge of this to solve this issue, and it's going to send the information. That's how it works. That is the neuron. So the neuron is the smallest living organism that makes up the nervous system. The neuron has three parts: the dendrites, the branches that are attached to the cell body which contains the nucleus, which is the brain of the cell, the one that processes these signals, these impulses, this information, and then has an axon, which is the one that brings the information to the correction, the solution, the response to the area that is being affected. So that's how it works. Think about the cell as the cell body. So the cell body is a restaurant. See, cell body is a restaurant, another example. Then you have all these lines, telephone lines, internet, and you outside here, you're gonna place an order. That order enters to these phone lines, internet, whatever other phone, or you just stop by and then someone right here is gonna be taking care of you. You place an order, and then if you place your order online or something like that, someone is going to be doing the delivery. Here, somebody is going to be cooking, processing whatever you need, and then they're going to send the delivery person to bring the food wherever you order it. That is exactly the same. That's what the cell does inside our body. But remember, we have millions of cells, and they are forming chains. So here there's another cell, here there is another cell, here there is another cell, and they are all over our body, all over. Any questions about the cell function, the supporting cells, the parts of the cell, the function of the parts of the cell. Because that's what's important, just to understand all the functionality of the structures that we have in our body. Because if we don't understand them, well, we don't know what they're there for. Okay, let's talk about this particular topic, which is called the synapse. Synapse. So what is the synapse? The synapse is nothing else than the space in between two neurons. See, this is the space in between two neurons. That is the synapse. Remember that I told you that the neurons are connected to other neurons, connected to other neurons, connected to other millions of neurons. So this space, when they connect each other, is called the synapse. This is the space where they are connecting. So this is the axon right here. This is the axon. And these are the dendrites right here connecting. Because axons connects with another dendrites from another cell, because that's how they pass the information from one cell to the next. This is like when you transfer in trains. You transfer in this particular base station, and then you take the next one. So that is how you connect. They are connected. It says right here, a synapse is the site space at which a neuron transmits a nerve impulse. So this impulses comes traveling right here, and it passes to the next one. See, the impulses comes from here. They reach this cell, then it goes through this axon, now to this other dendrites cell body, to another axon. So this space right here, the impulses are dropped right here in this middle space, right here at the synapse. So this neuron brings chemicals. Those are called the neurotransmitters. It says right here, the neurotransmitters. The neurotransmitters are the ones that brings the impulses. So those are like little vesicles like these ones, and inside it is some chemicals that are called neurotransmitters. And those neurotransmitters travels all in these capsules, and they are deposited right here in this space, and then the other neuron let them pass through these channels. That's how it is. Once again, think about you transferring trains to reach your destination. And every platform where you transfer, then you came from the train, they drop you right here. So the train is the neuron, and you are the chemical. Now this chemical is going to jump into another train because it goes somewhere else. So that's how this happens. So neurotransmitters are those chemicals that are transmitted in between the neurons. That's basically what it is. Those chemicals that we use to transfer, to capture those signals, those impulses from the inside of the body or the outside from the environment, are transferred in a way of chemicals. So some chemicals are the ones who are going to be transferring this. And they're going to be passed to the next neuron, to the next neuron, to the next neuron, until they reach their destination. They're going to go to wherever they are needed. Now it says right here, we have something that is called the presynaptic neuron. Very simple, very simple. I'm gonna explain it to you. Pre means before. Well, if you took medical terminology, you will know it. If you didn't, no problem. Pre always means previous, before. Presynaptic, synaptic is the synapse. So this neuron that is depositing, that is bringing the impulses to the next neuron is called the presynaptic neuron. And the one that receives is going to call the post. Post is after. Postsynaptic neuron. So one is bringing and sending these neurotransmitters to the next one. The one that brings the neurotransmitters is called the presynaptic neuron, and the one that receives them is called the postsynaptic neuron. That is basically what it's telling you. The difficult thing right here is to remember these names. But remember, pre and post. Prenatal, postnatal, premenopausal, postmenopausal. Oh, I understand now. Premenstrual, pre-postmenstrual period. Pre-med, post-med. Any of these things works. So it shouldn't be a problem trying to figure it out which neurons brings the neurotransmitters, the chemicals, to another neuron, what is called. That's called the presynaptic neuron. The other one is called the post because it's the one that receives. Any questions? Now, what I want you to remember is the synapse and the neurotransmitters. What are neurotransmitters? Chemicals. Neurotransmitters are chemicals. So those are the only things that you need to understand. What are neurotransmitters? Chemicals. And because it says neurotransmitters, they belong to the nervous system. So they're going to ask you, what is the space in between two neurons called? The synapse. The synapse. Remember that they can invert this question. They can ask the space in between two neurons is called the synapse, or they can tell you, what is the synapse? Then you're going to say, oh, the space between two neurons. Remember, you have to know in and out the questions. It's not that you go home from your work and then you forget how to return. That's not how it works. So you need to know both sides. And that's how you are going to understand this. So once again, the names are a little difficult because these are medical terms. This is not English. Remember, medical terms are derived from Latin and Greek. And none of us speaks Greek or Latin. I mean, as far as I'm concerned. But even though if you speak Greek, not Latin, because nobody speaks Latin anymore, well, I never learned that. I was never taught to me. So this is a language that is long ago gone, not spoken. But the textbook still keeps all these medical terms, and we're going to be seeing these medical terms through the entire course. Medical, that's what medical is all about. Okay. Any questions about the synapse, the neurotransmitters? Okay. Clinical application. This is one of these conditions that is very common. Remember, not the only, there are more, but this is one example that they gave you, multiple sclerosis. because it's damage to the central nervous system neurons. So that's basically what it is. So multiple means many. Sclerosis means an abnormal condition of kind of sclerosis, making it hard. Instead of saying soft, it makes hard. So kind of paralysis. We're talking about the skin, the muscles. So the neurons, let's go back here, are the axons. These axons are covered by some kind of, well, without saying the medical term, that which is myelin, but this is like kind of some insulation kind of thing that has right here. These are the wires, remember, electrical wires. So these electrical wires have to pass here because it's going to bring the impulses away from the cell. So these structures right here are covered by some greasy, some substance that is going to allow the impulses to move from one of these beats to the next one, to the next one. So once again, these structures are covered by this substance that allows electrical impulses to move through these shape bead structures. Now, during this condition that is called multiple sclerosis, this shift of substance that allows electrical impulses to pass, that is called myelin, is not there anymore. It's damaged. So then the impulses cannot travel to the axon, to the next cell, to the next cell. So if I don't be able to transport myself to my workplace, well, I'm not going to be able to make money. I'm going to be replaced. I'm going to be fired. Well, here within multiple sclerosis, that is exactly what happens. The destruction of the myelin sheaths right here in the central nervous system is this waxy structure that is on top of the axon that is being destroyed. It's not produced because that wax-like substance is produced by the same cells that it's made of, these Schwann cells. But I don't want to go into much detail because then you're going to get confused. So that's what I said. This cable right here that leaves the cell body is waxy. And this waxy substance is called myelin. And this myelin is the one that allows the impulses from the cell body to move through the axon to the next neuron, to the next neuron, to the next neuron. But if this waxy part is not there because it has been destroyed, because these cells, the Schwann cells, are not producing it, because you have a damage into the central nervous system, then the impulses cannot go. And these impulses, if they are going to the skin, the muscles, they are not going to be able to contract. If they are not going to be able to contract, then they're going to paralyze. If they're going to paralyze, they cannot do their function. So that's what happened to multiple sclerosis patients. The muscles paralyze. But these muscles paralyze from top to the bottom of our body. So they start on the face. So there are some people who have this condition. I believe that there is this actress called, I don't recall, that was, what was the name? Christina Applegate, something like that. And she developed this condition and she no longer is an actress because what happened to her? Her muscles paralyzed. She cannot no longer move. She's in a wheelchair. So that's basically what it is. The muscles become stiff because they cannot contract, because the nervous system cannot reach that area to contract it. They are not there because they have blood vessels. So they have nutrients, they have everything, but they cannot move. This is like paralyzed. And they start from the face, then going down. And when it reaches the lungs and the heart, that's it. This person will be dead. So there is no cure for this. You're going to take medications, but these medications only kind of delay the process. The process is going to happen, but it's going to be delayed. So the person doesn't die right away. So that's called multiple sclerosis. Remember, we have Parkinson's disease as well. It paralyzes some of the muscles. That's why these people who have Parkinson's, they kind of shaking, they don't have control over the muscles. So again, we have Parkinson's, we have the other one, I forgot the name, but it's when, dementia. And the worst part of dementia, when you completely lost memory, that's another one. Alzheimer's, that is a nervous system condition. So Parkinson's is a nervous system damage. So Parkinson's, Alzheimer's, multiple sclerosis, all are affected by the nervous system. If the nervous system doesn't work, then certain structures of the body that do not receive those impulses, those stimulus, that contraction, they're not going to be able to function. So that's basically what it is. So instead of having here only multiple sclerosis, we have Alzheimer's and Parkinson's disease, the most common conditions that we kind of familiar with. Any questions about this first part of the nervous system? Well, we're going to move to the second part. Oh, we did this, we did this. Oh, what happened to the other chapter? It's probably here. The neuron. Okay, intercommentary. Oh my gosh, what is all this thing? The nervous system, the nervous system. Oh, what is the neuron? I'll do it right here. Oh, here it is. Okay, so these are the divisions of the nervous system. Let me share this with you. Okay, these are the divisions of the nervous system. Remember, the nervous system has 3 short chapters. I summarize them because it's a lot. It's a very difficult chapter. So I'm trying to summarize and give you the most basic information about the nervous system so you can retain some of the information, not to make it complicated. So the divisions of the nervous system, we're going to talk about the central nervous system and the peripheral nervous system. You need to know these terms because these terms comes on national exam. So here we have them. So what is the central nervous system? Think about this. You just need to know about structures. The brain and the spinal cord makes up the central nervous system. So remember, very important. What about the peripheral? the peripheral nervous system, or PNS, central nervous system, or CNS. It's not CNA, it's CNS, PNS. The PNS, the peripheral, are the somatic nervous system and autonomic nervous system. Now think about this, because the brain and the spinal cord are the axis of the central nervous system. That's what is called the central nervous system. Now, the peripheral is wherever comes from the brain are those nerves that derives from the brain and from the spinal cord. Those are the peripheral. Some of these nerves will be somatic, meaning the ones that controls the skeletal system. Remember, that is voluntary. So somatic means voluntary. Are these contractions that we consciously control them? I can control them. Remember, I can make a fist, I can open my fingers, I can raise my arm, I can jump, I can do flex, I can do so many things, because I'm commanding my skeletal muscles to do so. But we have other muscles, other nerves that do not, you cannot control it. They are non-conscious, they are automatic. So remember, somatic is voluntary, automatic, non-voluntary, conscious, non-conscious, not unconscious, non-conscious. So these are the major divisions of the central nervous system. So we're going to see all these central nervous system functions and the peripheral nervous system functions. We're going to name some of these nerves that makes up the peripheral nervous system and the central nervous system, because that's what is this chapter all about. And what is it that they control? What is it that they do? I just gave you a little heads up on this chapter, but there are more. So these are the divisions of the nerve. These are not be careful, these are not the divisions of the central nervous system. No, these are the divisions of the nervous system. The nervous system, it is divided into central nervous system, or CNS, and peripheral nervous systems, and PNS. Now, the brain is part of the central nervous system. The spinal cord is part of the central nervous system. What about the somatic? The somatic is part of the peripheral nervous system and the autonomic peripheral nervous system. But then we're going to have more divisions. The brain is going to have some nerves. The spinal cord is going to have some nerves. The somatic is going to have some nerves. The autonomic is going to have some nerves that derive from them. Because remember, this is a network that, all these cables inside the walls of our home. So let's talk about the central nervous system, brain and spinal cord. Very simple, or very simplified, if you will. The brain. The brain is made of the cerebrum and the cerebellum. Brain is made of the cerebrum, which is the largest part of the brain, and the cerebellum, which is the second largest. So that's basically we need to understand. Very basic. The spinal cord links the brain with the rest of the body. So let's look at this image, and then you will understand it. So here we have the cerebrum. This is the cerebrum right here. And this is the cerebellum. So this is the largest portion of the brain, the cerebrum. This is the one that contains all these parts that controls every function of our body. This small part right here just control few things that we're going to mention later on. And the brain is connected right here to the spinal cord, which bring all the information from the brain all the way to the hips, where the bone ends, remember, when the spinal cord ends. But then we're going to have a bunch of nerves that comes from the brain, because they have to, well, how do you control your eyes? Well, because we have some nerves that comes from the brain. How you control hearing? Because some nerves that control the brain. Smell, because nerves from here. Taste, brain from here. And then some nerves from the spinal cord. Why? Because they're gonna go through every single branch of our body. The arms, the legs, the trunk, everywhere. Because remember, this is a network of cables. This is a bunch of cables right there that brings back and forth all this information that is going on in our body and from the outside, the environment. Remember, if I'm talking to you, I'm not inside of you, but you're hearing me and you can see me. So I'm outside. If it is hot, you're feeling the temperature. It's outside, it's the environment. If it is cold, the environment. If somebody pinch you, somebody hits you, it's from the outside. But it can be also the organs that are not functioning correctly. They are not producing the chemicals, the electrolytes, the hormones. They are not transporting the nutrients correctly. So internal, external stimulus. So these are the two parts of the brain. Remember, the cerebrum and the cerebellum. Remember, the cerebrum and cerebellum and the spinal cord. So here it is. So the spinal cord is just this cord that connects the cerebrum to all other parts of the body. So that's basically what it is. Any questions about the brain and the parts? Remember, cerebrum, cerebellum. The other part is the spinal cord, because this is the central nervous system, which is made of the brain and the spinal cord. But the brain has two major parts, the cerebrum and the cerebellum. Okay. So let's talk about this membrane that protects the brain and the spinal cord. It is called the meninges. So we talk about the meninges in another class, but for those who are new, no worries. This is the membrane that protects the brain and the spinal cord. This membrane contains 3 layers, is made of 3 layers. The first layer is called the dura. Don't worry about matter, because the last name is matter, so no worries. The first one is the dura, the second is the arachnoid, and the third one is called the pia. These are the 3 layers of the meninges. See, the dura is the outer layer, the arachnoid is the middle layer, and the third one is the pia, which is the inner layer. See? Middle layer. That's what I want you to remember. Things that are simple. So that's basically most of the stuff about the meninges. The meninges protects the brain. Remember, this is discussioning outside the brain. So whenever we move, we play, we do sports, so we hit, somebody hits us, we hit something with the head, the brain doesn't get damaged. Of course, all depends of the type of trauma. If you have a motor vehicle accident or you fall from a high or somebody, shoot you or hit you with a bat on the head, well, of course, this is going to cause damage to the head. But for the regular routine activities of our life, we're going to be able to survive. Falling, that's not a routine activity of our lives. Being hit, whether by a bullet or by a bat or something else, this is not a routine. But we can play sports. Now, there are some sports that are very dangerous, like boxing, for instance. But we're not talking about this extreme because not everybody, plays boxing. But for the regular activities of our life, our body is prepared for this type of actions, activities. But this meninges protects these layers. That is basically what it is. So those are the only things that I want you to be concerned about. Whenever they ask you, okay, this is the membrane that protects the brain and the spinal cord. What is called? The meninges. That's it. What are the meninges? The membrane that protects. Remember, you need to know the answer in and out because you don't know how they're gonna state it, how they're going to phrase it or paraphrase it. So that's basically what it is. Anything else? Not to worry. Just 3 layers, the meninges. So here we have the meninges. So I'm gonna color them so you can see them. I'm gonna do different colors. So this is the dura. Think about, this is the dura. This is, let's change colors. Let me put green, so we change the color. This is right here in the middle, the arachnoid. And last but not least, let me do this yellow. And this is the pia. So remember, there are 3 layers. It's a very tiny membrane, but it protects the entire brain and the spinal cord as well. See, they have this lining on the outside, these 3 membranes. So this is the end of the spinal, the spinal column, and within, this is not this short, this is very long, but it's just for you to see that that's how it connects the brain to the spine. So these are the meninges. Now, this bony part, which is the skull, remember, right here, this skull has some ridges. It's not completely flat. So whenever we do a bad, movement of the head, not bad movement, let's say that we fall or somebody hit us, these ridges can penetrate to this membrane and they can make you bleed inside. And that can cause internal pressure inside the brain, and that can cause us to die if we are not being taken care right away. So once again, the meninges are just these membranes that protects the brain, and it has 3 layers. The outer is called the dura. Think about dura. Dura is something that is very strong. The arachnoid, well, that's kind of hard. And the pia, that's the inner layer. So that's basically what it is. Any questions about the meninges? Remember, I make it very simple, very basic, so you can remember what are the meninges. Because this comes an exam. So as soon as you hear the meninges. One more thing. Remember, when the patient develops an infection, whether it's viral or a bacterial meningitis, then the meninges swells up and you develop headache and you develop neck pain. These are the symptoms that the patient presents with. And then we know that this is meningitis. And meningitis can be diagnosed by removing the cerebrospinal fluid. See the liquid that runs right here through these chambers is called the cerebrospinal fluid. So we have to remove that through a spinal tap, lumbar puncture. So then we know what is it that is affecting the patient, whether it's a bacteria or whether it's viral, or it's a virus, because viruses and bacteria can cause meningitis. If it is bacterial meningitis, it's very, very dangerous. It's very contagious. It kills versus viral meningitis. So bacterial meningitis is worse. Okay. So remember meningitis? We talked about that already. So this is the brain. This is a real brain. So if you see this area right here that we see, all these areas called the cerebrum. See, the cerebrum. And this small part right here is the cerebellum. The cerebellum. So the cerebrum is the largest portion of the brain. That's it. So this is something that, it is very important for you to understand. So the more you see it, the more that we cover it, then the more you're going to be remembering this. That basically, see, this is the brain. Has two parts, cerebrum and cerebellum. Well, let's talk about these major structures or divisions of the cerebrum. Remember, we talk about the skull. Remember the skeletal muscle, the skeletal system? When we talk about the bones of the cranium, of the skull, well, it's going to be easy now because the name of the brain parts, structures, depends on which bone is covering it. So the same names that we gave to the cranium, the cranial bones, is the same names that we're going to give to the brain structures. So we have the frontal lobe, the parietal lobe, the temporal lobe, the occipital lobe. See, with the frontal bone, the parietal bones, the temporal bones, the occipital bones. See, and we have the same amount. So instead of called bone, these are going to be lobes. The frontal lobe, the parietal lobe, the temporal lobe, and the occipital lobe. So here we have them. This is the frontal, which is all these gold color. See, this is the frontal. That's it. So now we are going to have the parietal, which is, let me use different colors because otherwise it's not going to be seen. So this green part, this is going to be the parietal. But we have two, remember, the right and the left. So this will be the parietal. Now we have the temporals. Let's change colors. Oh no, this is the same one. So this is the temporals on the ear side, one on the right, one on the left. And then we have the occipital. So let's put it this on this color. This is the occipital on the back. So we have one occipital, two temporal, two parietal, one frontal. One frontal. So that's it. Said right here that these structures of the brain or the cerebrum, the lobes, are named for the bones that they underline. Remember, the cranial bones. That's basically what it is. So it's nothing new. It's kind of repeating this, but with the difference than one where the parts of the bones, the cranium, and the other ones, they are the parts of the cerebrum. So that's basically what it is. Now let's talk about the layers of the cerebrum. Remember, we have the cerebrum, we have all these parts, these structures, but now we're going to talk about the walls, the layers of the cerebrum. Every single organ is made of walls. See, the skin has 3 walls, 3 layers. The bones have 3 walls, 3 layers. The cell has 3 parts. Well, the cerebrum is an organ, therefore it's going to have parts. It's going to have layers or walls. So this is what I want you to just remember, the simple part, the basic part. We have the cerebral cortex, which is the outer layer. The cerebral cortex. And the inner layer, which is called the medulla. But then it can be called the white matter, because this is the gray matter. So the cerebral cortex, let's type it right here, because cerebral cortex or gray matter. Cerebral cortex or gray matter. Remember, it can be called either or. Let me remove this. Or gray matter. Oops. Gray matter. See, it's the same. So when we talk about the gray matter of the brain, it's the cerebral cortex, the outer layer. This is the medulla. The medulla, or white matter. So let's remove this cerebrum. I don't like this. Right here, which is the inner layer. So that's basically what I want you to remember. Whenever you hear about the walls, the layers of the cerebrum, the outer layer is called the cortex. Don't worry about cerebral, just the cortex, because it's the cerebrum that we're talking about. Or gray matter. And then the second will be the medulla or white matter. Well, why is it that it's called gray? What is that is called white matter? Because it's very commonly used, white matter and gray matter, believe me. So medulla, cortex. See, I start changing things because this is kind of redundant, too much stuff. I don't like it. So we're gonna leave it just like this. The cortex of gray matter, the medulla of white matter. Well, remember that I told you that the axons are covered of myelin. And myelin is a white substance, this waxy stuff that allows the impulses to be moved, transported to the axons. It is colored white. Well, the medulla is made of axons. And because the axons contains myelin, then the medulla is gonna look white. That's what it's called, the white matter. White matter is just the white kind of tissue that is there. Matter, that's what it means. What happened to the gray matter? Well, the gray matter is made of dendrites and cell body. It's right here. And because dendrites and cell body do not have myelin, they're gonna look great. That's basically what it is. So that is the reason. So just in case you have a question and they ask you like, white matter, what is the medulla called the white matter? And you said then because of myelin. Myelin. So the myelin is this structure within the axons. Myelin is not within the dendrites of the cell body of the cell. So for that reason, they change colors. That is it. So no more information about this. So the cortex or gray matter and the medulla or white matter. That's it. So let's say that we have right here the brain. Oh no, let's go back to the brain. I'm a very, very bad drawer, so I don't know how to draw anything. So I'm very bad at it. So let's put it away right here. So, well, let's see. Right here. If you see this picture, this is white, you see? Because this is the medulla. And this other part is gray. Well, this looks like gray to me. So let's put it that this is like the head, right? But this is not what we're talking about. This is the next one right here. This supposed to look gray, this part right here. So it is white and gray matter. So gray matter is the cortex, the white matter is the medulla. See, the picture have the color because that's how it is. So the impulses goes from here, from the external to the internal, to all these nerves, to the spinal cord, and distributed to all the nerves of our body. From all the nerves that comes here. So that's basically what it is. So just in case, usually these questions are not arising on the test, but you need to know the central nervous system, the brain, and the spinal cord. You need to know the meninges, that this is the membrane that protects the brain and the spinal cord. So it protects the central nervous system. So that's basically what. And just in case, haven't seen this, but you never know, things are changing. If they ask you about why it's called the white matter, and it's because myelin. Remember, myelin. Anything else? No worries. Very simple. Any question about the layers or walls of the cerebrum? Okay. the cerebrospinal fluid. See how does nutrients, hormones, and things like that, besides the bloodstream, brings things to the brain, to the spinal cord, and to the nerves. Well, then it's through the cerebrospinal fluid. Cerebrospinal fluid, or CSF. Keep in mind, cerebrospinal fluid. So this cerebrospinal fluid, it is produced within the ventricles. We are not talking about the ventricles of the heart. These little lagoons or little lakes right here inside the brain are called ventricles, because they are just cavities. We have on the right, on the left, in the middle, and right at the exit of the brain that connects with the spinal cord. So we have two views, one that is sagittal, the other one that it is transverse. So here we have two views. So these are the ventricles, or these ventricles are interconnected because the fluid is produced here and it travels through the spinal cord. So that's basically what it is. See, they are interconnected. These are cavities within the brain and spinal cord. So we have one spinal cord and three over here. So we have four ventricles. It's not that you're going to be asked about how many ventricles, no. So they're going to ask you, where are the cerebral spinal fluid located or produced? Well, the central nervous system, the brain, and the cerebrum, and the spinal cord. We have two lateral ventricles called the first and the second ventricle, two laterals. Remember, these ones are laterals. One on the right brain, the other one on the left brain. And then the third ventricle, which is in the middle right here. See? And then the fourth ventricle, which is the one that connects with the spinal cord. And what is it that these ventricles produce? The cerebrospinal fluids. So that's basically what is important. Remember, when we need to do certain evaluations about the nervous system, we're going to withdraw, we're going to remove the cerebrospinal fluid so we can evaluate what's going on with these structures. So that's basically what it is. So just remember CSF, cerebrospinal fluid, just in case you have this. So these are the areas of the brain. Remember, we already mentioned them: the frontal lobe, the parietal lobe, the temporal lobe, the occipital lobe. And then we're going to talk about the cerebellum, which is this small part right here underneath or in the inferior part of the brain. And certain other structures that are very important for the functioning of our body. So we're going to go over this when we come back from break. Remember, because we have very detailed information about what are the major functions of each one of these regions of the cerebrum, and what are the functions of the cerebellum. So we're going to focus on this when we come back. So let's take a break. So right now it is 6:55. we're gonna come back at 7:25. So I'm gonna give you 30 minutes, okay? So 7:25, we are going to come back and continue with this chapter. Got it? 7:25. See you then. Enjoy your break. Hello. Okay. So we are back.
Hi.
Okay. So we're gonna continue with the nervous system once again. So we're gonna finish it up and see if we're gonna have time to do more or we're just gonna end right here. Okay. So let's go back to these the functions of these different regions or parts of the brain. So remember the parts of the brain, we have the frontal lobe, we have the parietal lobes, we have the occipital lobe, and we have the temporal lobe. Some of them are going to be easy for you to remember what the functions are. Some of them, not so much. But the good thing is you will not be asked about the functions of the parts of the brain or the cerebrum or else. So maybe one little question right here I might throw right in there that might be on your exam. But other than that, no, usually these topics are a little kind of too complex and they don't like to ask. So let's talk about the frontal lobe. Remember, the frontal lobe is the part of the forehead. So which functions this frontal lobe actually is responsible for? Thinking. So when we are thinking about something, when we kind of go around and try to figure out something, which is thinking, that is nothing else, nothing more than the job of the frontal lobe. Thinking. Memory. Remember, thinking and memory are not the same. Memory are all this information that it is stored in our brain and that can be retrieved when we encounter these situations. Let me give you an example or a few examples because it's not difficult. You read something and then you encounter the situation. Well, it's part of your memory of the frontal lobe that stores this information. Remember that the nervous system definition is a network of structures that captures impulses, stimulus from the outside and from the inside. It brings them to the brain and then sends a response. So the memory is the part that keeps all these stimulus, all these signals, all these things that we see, that we hear, save it somewhere within the brain. But in which part of the brain? The frontal lobe. That's why we learn something and then we remember some of this stuff. They become very familiar with us when we constantly using it. So you see somebody on the streets and you met this person like 5, 10, 20 years ago. And this person say, hey, how you doing? I remember you. I went to school with you. That is due to memory.
Que venga y yo trabajo de esa construcción que gana muchísimo y me mantenga y ya.
Hello? Any questions? Okay.
No, sorry, my bad.
Okay, just keep your microphones a little close right there. No problem. Okay, so that's basically what it is. That's memory. So we're going to store information. We gather all this information from external sources, from internal sources. We know when we feel thirsty. We know when we feel pain because we recognize pain. We recognize taste. when we are hungry, because all these are functions for our body. And the nervous system is the one that connects all these functions. You remember this particular address, this particular person, this particular house, this particular car brand or cellular. I remember the first cellular that I had. I remember a lot of stuff because of the memory. That is the frontal lobe. Remember, thinking, when you start thinking, that's part of the frontal lobe. Behavior, the way that you portray yourself, that has to do with the frontal lobe. If you are rude, if you are nice, if you are very pleasant, you are very charismatic, all those things, all those traits of behavior, those are, if you are, a bullier, you're going to remember that. If you're the person who always being quiet in the class, very introverted or extroverted, that's behavior, how you behave yourself. That is controlled by the frontal lobe. Movement. Now be careful, do not mix movement with these other parts of the cerebellum that we haven't spoken about it, which is balance and coordination. That's a different thing. Movement right here, on the other hand, means how the muscles contract, how the organs like the heart beats, all the movement of our organs internally and the skin, how all these cells moves from one place to the next, how these signals, electrical signals from the heart makes the heart to beat. So that is what we're talking about, movement. The way that I move my mouth, my tongue to speak, that is something that is controlled directly by this part of the brain. Later on, we're going to discuss the cerebellum, this small part of the brain, the inferior part of the brain. That is a different issue. Let's talk about the parietal lobes, which is this area right here. Remember, these are the ones that are on top of the head. We have the right side and the left side. So what is it that these particular areas of the brain, of the cerebrum, are in charge to do? Language. So if you have problems understanding, learning new languages, well, this is the part of the brain that you have to deal with. The parietal lobe. So some people learn several languages. Some other people, we have problems learning certain things. So a language, how you learn the language. So that's basically what it is. So now it's not how many languages you learn, it's the languages that you are able to handle. So language, when you talk, people are able to understand you. That's basically what it is. So if you have problems with speaking, because you have some issues within this part of the brain, so that is language, not necessarily the learning process, because the learning process is done by the temporal. So we will clear this up. So language is whether they understand where you're talking the language or not. I'm not talking about that they understand English when you do not speak English. That's not, because it has nothing to do with that. I'm not going to understand a language that I've never been exposed to it, that I have never learned. I'm talking about how you speak and whether other people understand you or not. The parietal lobe also controls touch. So when you feel the touch of someone, you're going to understand whether this touch is an effective touch or it is an assaulting touch or an unwanted touch. So that's basically what it is. Your brain differentiates between somebody kind of caressing you or somebody assaulting you. That's touch. And we use this a lot in medicine because we do certain parts of the body and we do not say we touch, we palpate the area of the skin to see if you have the feeling of the skin or you lost skin or muscle or any other part of the body sensation, if you will. So if you have these sensors of touch, if they are functioning correctly, if these receptors are sending the information to the brain or they are not. So that's basically what we're talking about here, touch. Let's talk about this back part of the brain, which is called the occipital lobe. The occipital lobe is the back part of the brain. This one right here that is in green. So this part of the brain is mostly in charge of controlling sight, meaning vision, your vision. So if you have trauma to this part of the brain, you're going to lose your vision. Because the eyes, our eyes are connected to some nerves with the occipital lobe. So if there is damage to these nerves that connects to the eyes, then we will have problems. But those nerves are connected to the occipital lobe. That's basically what it is. So sight, vision has to do with the occipital area of the brain. That's basically what it is. Let's move to the parietal. Oh, I'm sorry, to the temporal lobes. Just checking color right here. This is the temporals. Now, once again, oh, what is my temporal? No, I didn't select it. So here it is. It is marked right here. These are the temporals. So think about here which structures are located here. The ears. So we have hearing, learning, and feeling. And feelings, I'm sorry, not feeling, feelings. So let's talk about each one of them. So all the nerves that are connected to the ear comes right here from the parietal, from the temporal. Oh, what am I talking about? From the temporal lobes. So the temporal are the ones that provides all the nerves for hearing. So if we have problems with the temporal lobe, well, then we lose the hearing process. Now, here is where learning comes to play. So the other one was languages. Remember, speaking the language that you know that can be understood. That was the parietal lobe. Here is learning. Here is actually the way that you learn, how easily you learn a new language. So that's basically what it is. Or learning a new subject. How easy it is for you to learn this material, to learn that particular material, and so on and so forth. There are some people that learn things very easily. Now, the technique of learning, we're not talking about that. It's just there is a complex of things that help you to learn something. We're not going to talk about that. It's just we're talking about the area of the cerebrum that assists you with learning. How is it that some people learn things so fast, so well, and some other of us might have problems learning? So it has to do with this part of the brain. Feelings. When you feel sad, when you feel happy, when you are stressed out, all these feelings about well-being are part of or are associated with this particular law, which is the temporal law. That is it. So you have this light, this image, you can go and refer to it. But usually these are not common questions for exam, except we're going to talk about the cerebellum, which is this part right here that I'm going to highlight. Remember, this is the second largest part of the brain because the brain has two parts, the cerebrum and the cerebellum, which is this part right here. So what is it exactly that the cerebellum does? It controls, it maintains balance and coordination. Balance and coordination. Balance meaning that you, when you're walking, you're not falling. When you lose your balance and you constantly falling, that is a problem with the cerebellum. Now be careful, because if you have a condition that causes you dizziness, or you become very dizzy, or you have vertigo, that is related to a medical condition, remember. It might be your spinal cord and the cervical area, the neck, or might be your temporal lobe, your ears. So those are very different things. We are talking about losing balance. Like Parkinson's disease, remember, which is very unstable person. It can fall. It's continuously shaking. So that's a different issue. So when you start losing balance and you don't know how that happened and you don't have any condition related to, or at least you haven't been diagnosed with vertigo of dizziness, then probably you have this malfunction with the cerebellum. Balance and coordination. So sometimes during national exam, because this is so particular, they're gonna ask you, what is the job of the responsibility or the function of the cerebellum? It maintains balance and coordination. Remember, balance and coordination, it is controlled by the cerebellum. So just in case you encounter this question, this is one of the questions that probably is going to come out on an exam regarding the brain, once again. Except we're talking about the functions of these areas of the brain. So balance and coordination, think about cerebellum. Nothing else. There's nothing else going on right here. Okay, any questions? So the cerebellum, we're going to talk about its locations. And once again, we're going to talk about the function because we just kind of summarize something by looking at the image. But here it is, the cerebellum, located inferior to the occipital lobe. Remember, it's this part right here. It's inferior, it's underneath, it's below. Now it coordinates skeletal muscle activity. Remember the muscles. If you lose control, lose balance, lose coordination. So it says right here, maintains body posture and position, meaning it maintains you balance. So you're walking and you're walking straight, you're not kind of sagging or moving to the sides or anything like that because your cerebellum is controlling that. But if your cerebellum malfunctions, then this is what you're gonna do. Present with these characteristics. So that's basically what it is. Not much to talk about the cerebellum. Moving on, let's talk about the spinal cord. Well, the spinal cord is a little more complex. The brain, well, it doesn't have too many parts. The spinal cord, it does because it has a bunch of nerves or structures that branches off from the spinal cord. So we're going to mention some of them. Usually, very rarely is asked on exams. But as a part of the curriculum, we have to talk about this and we have to mention them. So you can familiarize yourself with some of the functions of this very important structure of the central nervous system, which is the spinal cord. Remember, central nervous system, CNS, it is made of by the brain and the spinal cord. So we talk about the brain already, and the brain has two major parts, which are the cerebrum and the cerebellum. And we talk about the functions of either of these two structures. Then we're going to talk about the other part of the central nervous system, which is the spinal cord. So this structure, as you can see, it begins right here at the base of the brain and extends all the way through the spinal column to certain area of the spine. So that's basically what it is. It says right here, extends downward through the vertebral canal. Because this is the bony part that protects the spinal cord. It is very sensitive. A little something happens to the spinal cord and you're gonna feel lots of pain. Or probably lose movement from that damage down. So it says right here, it begins at the foramen magnum. Remember, that's the little opening at the base of the cranium. So it is connected right there, all the way down to the lumbar vertebrae, but that will be between L1 and L2. So remember, it reaches more likely up to here. It's not going to go all the way down because remember, all the way down, these bones are fusing together. Remember the sacrum, which is connected to the lumbar region, which is this part right here, the lumbar region that we have 5 vertebrae right there. Well, we go up to the L1, the first one. So it doesn't go all the way to the 4th or the 5th vertebrae. No, it stops before. Why? Because here is getting very close to a part when we are going to have these fused vertebrae, and we don't want anything over there. So they can stop right here in this area around L1 and L2, which are the first 2 vertebrae of the lumbar region. So that's basically what it is. Now it says right here, it consists of 31 segments. So that means that we have 31 pairs of nerves that comes out from the spinal cord. They are called the spinal nerves. Remember that I mentioned already that from the brain, we're going to have some nerves that are going to be branching out. Well, the spine also has all these nerves. And all these nerves are coming out from all these joints of the vertebral column. So we have 31 pairs of spinal nerves. So be careful with this. Don't mix them up. Don't think that there are 31 pairs of vertebrae. That's not how it is. Remember, we have 26 vertebrae in adults and 33 in infants. These are nerves that are going to come out from these different sections of the spine, different regions. So that's basically what it is. So let's check the function. It says right here, the main function of the spinal cord is it is a conduit, it's a pathway to bring impulses to and from the brain. So think about this. Whatever is going on the outside or inside, here are the nerves. They are attached on both sides, and these nerves comes everywhere in our body, in every single structure. All these nerves. So they capture the impulses and they send it to this main pathway, which is the spinal cord, to the brain. And remember, the brain is gonna make a decision. It's gonna see what's going on, and it's gonna send the information back to the same channels to wherever is the problem or the solution needed. So that's what we are talking about. Because the main structures, which are, the central nervous system, they just are in the middle. But what about the peripheral? What about the organs inside, the skin? What about capturing something from the environment? Well, we have to have all these nerves that are going to be the pathways to pick up impulses from every region of our body, bring it to the spinal cord, and then to the brain. The brain is going to make a decision, it's going to decide what to do, and it's going to send an answer through the same pathway as the information came in. So that is what it's telling you right here. It's a pathway for impulses to and from the brain. See? Not complicated, so just know that. Now, let's move. We talked about already the central nervous system, which is made of the brain and the spinal cord. So we talked about that already. Now, we're going to talk about the peripheral nervous system, which is all these nerves that branches off from the center, from the brain, and from the spinal cord. So we are going to have, remember, peripheral means the surrounding areas from the center. That's peripheral. Now, as I mentioned before, the peripheral nervous system is made of, remember, the cranial nerves and the spinal nerves. So we have this nerve that comes from the brain and this nerve that comes from the spinal cord. So that's basically what it is. The cranial nerves, it says right here, arising from the brain, and this arises or derives from spinal cord. We have 12 cranial nerves, 31 spinal nerves. We saw the spinal nerves, but we never mentioned the cranial nerves, but we will see them. So that's basically what it is. So all these are, parts of the peripheral nervous system. Then we have, once again, remember the divisions of the peripheral nervous system, the somatic nervous system. Remember the muscles. This is considered voluntary. Remember, conscious activity, because I already explained that. And the autonomic nervous system, which is not controlled. It is autonomic, remember, just happens. So that's basically what it is. All of them are related to these nerves that we mentioned before, the cranial nerves and the spinal nerves. Cranial nerves. There are 12 pairs of cranial nerves. So once again, these nerves derives from the brain. That's what is called the cranial nerves. They are named using Roman numbers. Roman numbers. 1, 2, 3, 4, 5, 6, 7, 12. Roman numbers. So that's how we name them. The cranial nerves, remember? 12 pairs, but we use Roman numbers. Here are the cranial nerves. So we have it right here, how they divide, how they go, but this is a very difficult picture to understand. So we're just gonna mention them right here. Cranial nerve number 1. See, number 2, number 3, number 4, number 6. Oh, what is number 5? Well, guess what? We skip that one and we move number 5 after. You're gonna learn why, because it's a lot easier to go this way. Number 7, number 8, number 9, number 10, number 11, and number 12. So let's start with cranial nerve number 1. This is called the olfactory nerve. Olfactory is the sense of smell. So that's it. Olfactory, smell. So this is the nerve that controls smell. And what is smell? Your nose. Where is your nose? In the cranium. So for that reason, it has to be controlled by the cranial nerves, not by the peripheral, not by the spinal. It's got to be controlled by the same brain because these structures are within the cranium. It will be some exceptions, but for now, that's how it goes. Second nerve, the optic nerve. Oh, very easy. It controls the sense of vision. See, vision is controlled by the optic. Optic sounds like eyes to me, like lenses to me, so senses of vision. Some of these nerves are easy to identify because they kind of correlate with the English version of the name. So vision, optic, eyes, olfactory nerve, smell, well, sounds like, very similar. Here we have oculomotor nerve. Oculo means eyes. Eyes, like optic. Move the eyes because it's motor. Oculomotor. Motor means movement. Oculo means eyes. So it moves the eyes. That's number 3. See, olfactory, smell. Number 1, optic, sense of vision. Remember, it's how we see things. The oculomotor, which is number 3, related to the second one, has to do how the eyes move. We can move our eyes up, down, right, left. So we can see, move our eyes. That is controlled by these muscles that moves your eye are controlled by this particular cranial nerve number 3, which is the oculomotor. Now, another muscle that help you, that assists the oculomotor to move your eyes, the trochlear nerve, or the trochlear nerve. This nerve is nerve number 4, and this helps to move the eye as well. That's basically what it is. So we put all these together because they are related. I. And this is just the smell. We don't have anything else. Now look at these ones. Abducens nerve, number 6. Now, remember, we move number 5 because I'm going to group them with another related nerves. So it's going to be easy for us to remember them. So 2, 3, 4, 6. These nerves has to do with movement of the eye. Whether they pull the eye up, down, retract to the left, to the right, one of these nerves do one of those movements. We're not going to go into specifics, into details. We just need to know the name of the nerves and what is the main function. So that's basically what it is. So these names are very difficult. Trochlear, oculomotor, abducens, very difficult. Once again, if you ever have a question of these nerves, I'm going to tell you probably two of them that you might have. The olfactory, because it's number one. So they might ask you, which of the following is nerve number one? Cranial nerve number one. Then you're going to look for the olfactory. Or they're going to ask you, the olfactory nerve is also known as smell. Olfactory means smell. That's it. Anything else? Very seldom will be asked. So that's basically what it is. I almost shut down my computer. Oops. Totally forgot this battery thing. Okay, moving on. Nerve number 5. Now we're gonna group them because now we're gonna have number 5 and number 7, which are the nerves that controls the face, the muscles of the face. See, that's why it is important. Facial nerve. We have the trigeminal nerve. So this is a facial nerve. Facial nerve. Now, probably you are familiar with this condition. Facial paralysis. Bell's palsy is the same. Bell's palsy is the medical term for facial paralysis. When you feel that your face is kind of, you don't have sensation on one side of your face, but only your face, the eye on the particular side of the face droops, your mouth also droops. Now, do not mix these facial paralysis with stroke symptoms, because stroke, you paralyze the entire side of the body. That's different. The other ones, you can move your arm, you can move, you can walk. It's just your face that is the muscle of your face that paralyzes. So this is the trigeminal nerve, the one that causes all that. It paralyzes the facial nerve. Because the facial, the trigeminal, remember. The other one is the facial nerve number 7. This is the one that gives you the expressions. When you frown, when you smile, when you make things, then, when you move your face and make faces, all these facial expressions, if you will, that is the one that controls this one, the facial nerve. This trigeminal nerve, when you develop Bell's palsy, or which is the same as facial paralysis, is painful. You feel the pain in that area, but the muscles of that side of the face are paralyzed. Your mouth droops, twists, if you will. Your eyes also on that side of the face. If you touch, you poke yourself, you're not gonna feel anything because it's paralyzed. You lost sensation, you lost these nerves, they are blocked. So that's basically what it is. So that will be the trigeminal nerve and the facial nerve. That's what I put this nerve number 5, or the trigeminal nerve number 5, alongside with 7, because these are the facial nerves. Let's move to facial nerve or cranial nerve number 8. This is called the vestibulocochlear nerve. Vestibulocochlear nerve. Vestibulo, this is structures of the ear, the cochlea, and the vestibule. It says right here has to do with auditory nerve. So this is the nerve that controls hearing. If this nerve is damaged, you won't be able to hear anything. So people who's deaf, that's what they have the problems with. And the nervous system is very difficult to fix. So you might have certain devices implanted, things like that. But if you are deaf because of the nerves are damaged, that is not much that we can do. So that's why the patients learn sign language, because they know the way to communicate, or certain electronic devices. We even have a different language from them to use these electronic devices. So the vestibulocochlear nerve, nerve number 8, it has to do with the auditory nerve, remember, hearing. Here we have cranial nerve 9. It says the glossopharyngeal nerve. Well, if you took medical terminology with me, gloss or glosso means tongue. Pharyngeal is the pharynx. So this is the nerve that controls swallowing. When you swallow something, when you deglute something, when you put something in your mouth and push it down through the pharynx, through the esophagus, through the stomach, then this nerve controls that. So if you have problems passing down, if you will, instead of saying swallowing, degluting, putting something down your throat, that is controlled by this cranial nerve number 9. And it controls also taste. And where do we find those taste receptors? Within the tongue. Remember, medical terms, tongue means glossal. So that's basically what it is. Just kind of, get a little sense of all these nerves, that we have different nerves that controls different functions in our body. And if we talk about the cranial nerves, is something that has to be related with the face, remember, something that is within the face, because the tongue, the throat, they are very close right there because the tongue is connected to it. So that's what is called the glossopharyngeal nerve, which is the cranial nerve number 9. So moving on, any questions about so far about these cranial nerves? Remember, this is not a common subjects for exams. So usually I don't ask about this either because, well, you're not going to encounter this anywhere else. I don't even bother. Now we have the vagus nerve. This is cranial nerve number 10. So this controls mostly the internal organs. So that's basically what it is. This vagus nerve, once again, this runs through the throat, to the neck, all those things, and controls see, from here, controls every organ of our body. Can you imagine? It controls them. It controls their movement, not their functions. So it sends impulses to all these organs within our body. So that's basically what it is. It controls them. So remember, we're talking about movement, not actually the functions that they do. So controls internal organs. Remember, internal organs we call visceral or viscera. Remember, internal organs, that is very important to know that viscera or visceral pertains to the internal organs. That is different. So these terms as medical terminology can be asked in national exam. Okay, so we have now cranial nerve number 11. This is called the accessory nerve. The accessory nerve. This is like an extra nerve, so to speak. So remember accessory, all these accessory organs of the skin, kind of a little farther away from the cranial nerve, but they control it because it's not too far away. Remember, it's the neck. This helps to move the muscles of the neck, or the shoulder, the part of the back, the roll blades. So that's basically what it is. That's what it's called accessory, because it kind of moves a little farther from the brain. These nerves will not come out on national exam, except for the olfactory one. So that's basically what it is. Hypoglossal nerve, which is nerve number 12, last. So this alongside with the accessory nerves, they move a little farther away from the brain. It's not the eyes, it's not the ears, it's not the taste within the tongue, but it's kind of right there. So it moves the muscles of the tongue. Well, this is part of it. That's what it is connected to it. And remember, the tongue has to do with chewing, mastication, and swallowing. When you swallow something, has to do with the tongue, because the tongue assists this mass, this bolus of food that has been masticated, broken down. They make a bowl, and then we send it down through the throat and esophagus to the stomach. Well, that is what these muscles do. Remember, hypo means below, glossal means tongue. So below the tongue. So what we find below the tongue? The pharynx. And that is the throat. So that's how food are going to pass through it. So these nerves has to do something with participating in assisting with movement of these muscles. So you are able to talk, able to chew your food, able to swallow. That's basically what it is. Just for you to have an idea that this is going to be on exams, definitely not. So don't stress yourself much. But it is important, and it is part of the curriculum, and we need to give this information so you can get familiar about how our body works. It can be also something that for you to understand when you have problems swallowing, when you have problems speaking, not because it has problems with this particular part of the brain that is damaged. No, these muscles that helps these vocal cords to vibrate, to move, or just the food to pass down your throat. That you might understand that something is going on with these particular nerves that are controlling this muscle movement that assist these substances, these things to happen. So that's what is important about these nerves, because otherwise we wouldn't know how our eyes moves. How do we smell things? How do we differentiate between types of smells, types of taste, things like that? How can we hear things and other people cannot? So it is because all these nerves, the cranial nerves. So this will be the 12 nerves. Any questions about these cranial nerves? Moving on, spinal nerves. So we talk about the spinal nerves are those nerves that kind of, derives from the spinal cord. We have here in this image, we see all these nerves that goes on one side, but it goes in both sides. We have 31 pairs of spinal nerves. We're going to divide them. And they're going to be easy to be remembered because they are related to the spinal regions, the spinal cord segments, parts, regions, curvatures, whatever you want to remember. So you see all these nerves. As a opposed to the spinal cord, remember the spinal cord just reaches up to here. The cranial nerve, the spinal nerves, they go up to the coccyx. So all these areas, we have nerves in this area of the spine and in this area as well, because all these nerves distributes to every single part of our body, every single part of our body. So again, see, we have nerves everywhere. That's why we have 31 pairs of nerves. So if it is 31, that means that we have 62 spinal nerves. 31 on one side, 31 on the other side. So let's see how many cervical, 8 cervical nerves. We have 7 cervical vertebrae. That's totally different, but we have 8 cervical nerves. So C1 to C8. So please do not mix these up. Do not kind of mix these cervical nerves with the cervical vertebrae, because that doesn't work that way. There are 12 thoracic nerves. There are 5 lumbar nerves. There are 5 sacral nerves. There is 1 coccygeal nerve. So see the difference right here, 8, because we have 7 vertebrae. But we have not counted the one on top, the space where the atlas connects with the head. We're gonna have a nerve right there, because we're not talking about the vertebrae. We talk about the spaces in between them where these nerves are kind of derived from. And the coccyx, because the coccyx is fused, makes only one little bone. It has 1 nerve. Everything else have 5. So that's why we have 31 pairs. So this is a lot easier to remember because it's related to the vertebrae, the spaces in between the vertebrae, the number of vertebrae or regions. It just changes a little bit, but it's mostly the same. Any question about these spinal nerves? Not gonna tell you what they control, where is it that they're going to. No, it's just for you to know, just in case if they ask you how many cranial nerve pairs do we have? 12. How many spinal nerve pairs of spinal nerves do we have? 31. Just roughly base knowledge. So that's basically what it is. Not worry about much the rest of this. So let's move to the autonomic nervous system. So remember, autonomic means we do not have control over it. We don't. So the autonomic nervous system is part of the peripheral nervous system, which is PNS. ANS, autonomic nervous system. Please do not confuse this with CNS, which is the central nervous system, because we tend to mix things up when we are not familiar with these terms, because it's too much information. It functions without conscious effort. It's automatic, autonomic. It just does it by itself. The heart. The heart is autonomic. The heart does not follow our commands. We don't tell the heart to beat or to stop beating. We don't do that. The lungs. We don't tell the lungs inflate, deflate. Allow the oxygen to move in and the carbon dioxide to move out the membrane. We don't control that at all. We don't control how the blood runs through the blood vessels and passes through the heart. We don't. We don't control the liver when filters the blood, remove the wastes, and put the good stuff back into the blood flow. We don't control that. We don't control how the stomach mixes the food with all these acids, break it down, then filter, then absorb nutrients and remove wastes. We don't control that. They just do it. But we do control the skeletal muscle. Remember, that's the only one that we can control. Everything else, we don't. Controls visceral or internal organs activities. I already mentioned it. This autonomic nervous system is the one that controls the heart, the kidney, the pancreas, the liver, the intestines, the stomach, everything else that goes inside the internal organs, the brain, because we cannot control that. You cannot tell your brain not to think, not to memorize something, not to remember something. As soon as you see something, you're gonna say, listen, do you remember that you owe me $100? Oh, I don't recall that. Seriously? You don't forget those things. So this is controlled automatically by the nervous system, by this part of the nervous system, which is controlled. It's called the autonomic nervous system. This autonomic nervous system helps to maintain homeostasis. Remember, homeostasis is one of those questions that you will have on your exam. Oh, you bet. Remember, homeostasis means internal balance. So it maintains your blood glucose levels, cholesterol, potassium, magnesium, chloride, hormones, nutrients, water, everything has to be balanced inside our body. So that's called homeostasis. And the autonomic nervous system controls that. We don't control sugar. Oh, sugar, you're getting too much. I don't have sugar. Sugar be released, block sugar, block cholesterol, then we don't have no conditions because we can control it just giving a command. I just tell them, heart, stop beating. Oh no, don't beat so fast. Regain pumping. No, we don't control any of those. This autonomic nervous system helps the body to respond to stress. Yes, when we are in a fly or fight situations, this helps us out with the sympathetic nervous system we're going to talk about later on. But this is the one that reduces the stress, sending all these messages to these glands to produce these particular hormones or these particular neurotransmitters. So if we are very stressed out, if we are very sad or things like that, they kind of calm us down, they relax us. When we are tired, when we are angry and all those things, well, the autonomic nervous system is the one that sends all these signals to these glands. They release these chemicals. These chemicals comes to the area and act to calm us down, to relax us. Prepares body for exercise, intense physical activity. So remember that I said health body respond to stress. That's the thing. You are very tired, you are running, you are very, so many things going on. So you develop cramps, you develop this or muscle strains. Well, the autonomic nervous system tries to balance that out, sending what is needed, what chemical is needed to relax you. When you have a leg or arm, mostly the legs cramps, you don't stay with the cramp right there. It passes. It just gives you pain for a little while, and then you're not able to move that particular area or arm or leg for a little while, but it's for a short period of time. Then you regain movement. You again continue doing it. When you are exhausted because you are running too much and your body cannot keep up with that, you just relax and your body come back. Remember, negative feedback. It put you back to the state that when you were at rest. That is the autonomic nervous system. So very, very important system. Can you imagine if the autonomic nervous system is not working? Well, then none of our internal organs will be working. Not good, right? So that's how everything functions. We're going to move to the two divisions of the autonomic nervous system. I believe this is next, if I remember. Oh, yeah. The two divisions of the autonomic nervous system, sympathetic nervous system and the parasympathetic nervous system. Now, these two terms, you gotta watch out because these might be questions for exam. Remember, I'm telling you out of all these chapters, what might be possible questions for exam. So you can keep it in mind, so you can write a note right there in front of each of these terms and say, oh, question mark, probably exam question. Because this is really important. I mean, everything, every function of the nervous system is important, but for your program, for your level of education, these are questions that might arise during an exam. So this will be something that I would ask. So if I'm thinking that I will ask about this, well, I'm pretty sure that the person that is making these exams for the national certification is thinking the same way. Because these are questions that definitely I will be keeping an eye on it. These topics, by the way. Okay, so we have the sympathetic. This is called the sympathetic nervous system and the parasympathetic nervous system. These are divisions of the autonomic nervous system, and this belongs to the PNS. PNS, peripheral nervous system. What am I writing right here? Nobody's going to understand. PNS. So these are part of the PNS because the autonomic and the somatic and automatic, remember, somatic nervous system and the autonomic nervous system are part of the PNS. And sympathetic and parasympathetic are divisions of the autonomic. So that's basically what it is. So the autonomic divides in these parts. So that's basically what you need to know. So before we move any further, think about this. The somatic is voluntary. Remember, we saw that before. Somatic means skeletal muscle. These are parts of the nervous system that it is controlled consciously. So remember, the skeletal muscle is the only one that is controlled consciously. So I command my arms to bend, to stretch, to rotate. I do all these movements to close, to open my fingers, to bend down, to bend forward, to the side, to the left, to rotate my head, to rotate my shoulders, not my shoulders, my arms around my shoulders, my legs around my hips, and all those things that can be done because this is somatic. But then we have the opposite, which is autonomic, which comes from automatic, which cannot be controlled by conscious. It is unconsciously happening. We do not have control of it. Now we have sympathetic and parasympathetic. They opposes each other. Remember, if I have somatic, that is voluntary, we have autonomic, which is involuntary. If we have central nervous system, we have peripheral nervous system, the center and the one on the sides. The one on the sides and the periphery is peripheral. So that's how you have to look at all these terms. Because otherwise you're going to get confused. You're not going to know what is the central nervous system, what is the peripheral nervous system, what the central nervous systems are made of, the brain and the spinal cord, and what the peripheral nervous systems are, what the structures are. So that's basically what it is. So we need to kind of divide these things, put them together like cranial nerves, because they come from the cranium, from the brain, the part of the brain that, once again, is the cerebellum. So the sympathetic nervous system is part of the autonomic, but the autonomic is part of the peripheral nervous system, not the central nervous system. So that's basically what it is. So what does the sympathetic nervous systems do? Very simple. The sympathetic nervous system is the one that activates our muscles. Let's put it this way. These are the one that makes us hyper, make us to do something. This is the sympathetic nervous system. As opposed to the parasympathetic nervous system is the one that relaxes us. See, if this parasympathetic make me very active, very hyper, I cannot stay like that because then my body is going to collapse. So we have another part of the body that relaxes it, that opposes it. Again, negative feedback. See how important it is, the negative feedback? Because it's the one that reverses an action. Something that is going up, up, up. Oh, no, 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 you can go too up, too much sugar, too much cholesterol, too much sodium. Your heart rate is too high, your blood pressure is too high, your respiration rate is too high. No, 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 no. We got to bring it back to normal. We got to do this homeostatic state, balance, internal balance. So the sympathetic nervous system is the one that excites you. You are very excited, jumping up and down. The parasympathetic relaxes you. So when I'm very upset, my heart is trying to come out of my chest. I have all these palpitations. My respiration rate increases, my pulse increases, my body temperature increases. My attitude goes off the roof. But I'm not going to stay like that forever. Why? Because the parasympathetic system comes to the rescue and relaxes me. See how everything works? So we have systems in our body, nerves in our body that causes us to be very active, very hyperactive, if you will. But then we're going to have another part of the system that is going to calm us down. Remember, you can be as happy as you can, but you're not going to stay laughing all the time. You're going to stop. You're not going to be crying forever. You're going to stop because of the parasympathetic nervous system. It relaxes you. It brings you back to normal. That's basically what it is. Can you imagine if I have I lost someone, or I lost my job, or a property, whatever the case may be. I'm going to be very sad, right? But I'm not going to continue being sad forever. The parasympathetic is going to assist me. So that's basically what it is. So there is a term that we use a lot that is called the fight and flight response. So this is to apply the sympathetic action and the parasympathetic action. So let's say fight and flight response. Pay attention to this particular expression because this might come out on exams. Remember, the sympathetic and the parasympathetic are crucial because there is just something that excites me. It's caused by the sympathetic nervous system, something that relaxes me, or to calm myself down is going to be the parasympathetic nervous system. So it is important. Now, the fight or flight response is, I'm going to give you an example, how applies for the sympathetic nervous system. So the sympathetic nervous system is related to the fight or flight response. So let's say then you're walking on the streets by yourself and you see couple of individuals or one individual getting close to you. There's nobody else around. And this person looks very threatening. So this is the fight or flight response that the sympathetic nervous system is going to evaluate you, if you will, is going to assess what you're going to do in this situation. Or you're going to run like you never ran before, or you're going to confront this person. So the sympathetic nervous system help you to decide. You will do what the sympathetic nervous system is going to tell you to do. So what should I do in this situation? Should I fly or should I fight? So that's basically what it is. So when you see this concept, this expression, flight or flight, remember, fight or flight, think about sympathetic nervous system. Because all your, all your impulses, all your emotions are on the top. Because you have to make a decision and it's got to be fast. So your brain is stopping everything else and it concentrates only in this situation. When you encounter yourself in a situation of danger, you don't think about anything else. When you watch a movie, it says, oh, my family, my kids. No, you're not thinking about your family and kids. When somebody is pointing with you with the gun, it's me. They're going to shoot me. They're going to kill me. There's no time to think about family. There's not to think about money. There's no time to think about anything else. Who thinks about that? In this particular moment, that is something that happens suddenly. So that's called the fight or flight response and is related to the sympathetic nervous system. Any questions about the sympathetic or the parasympathetic nervous system? Or any questions about whatever we covered today? Anyone? I think that we finished. I don't know if there's another slide right here. I think that we finished. Yeah, we finished. We are doing really well. Look at this, covering a lot of material. But the good thing is that not many questions are going to come from this chapter. So I'm being telling you more likely what's going to be when it's not going to be. So for those two students that just joined the class, Darlene and Xiomara, this is the way that I give exams. At the end of this module, I'm going to give you a final exam. I don't do quizzes. I don't do midterm. I do one final exam. So this final exam, it will be a take-home test. You will have it for a few days, so you can review it, you can answer to your best of your knowledge, you have your reference notes over there. That's how I give my exams, okay? So do not panic thinking, oh my goodness, how am I gonna remember all these? Because the purpose of my classes, this is me. This is the way that I conduct my classes. The purpose of my classes is not to figure out who's the smartest, who memorizes more. No, hey, listen, you're adults. You have a lot of things to do besides just coming to the class. So if I was teaching these high school students, then I will quiz them every day. I will give tests, midterm and final, and that will be presential, right? Right there in front of me. Because these kids don't have anything else to do besides playing with their phones, using all these electronics and social media. Well, you gotta have some time for you, right? You guys have lots of responsibilities, not just work, family. So it's lots of things goes along with this. See, I do a lot of stuff. So I wouldn't have much time to read, to have a test, to have a quiz. Well, I'm trying to give you a little break with that. And up to now, every single student that I have given my test, they do it, they return it on time. So we have no problem with that. So you benefit from it, you do well, you review, because the purpose of the exams that I gave you is for you to review the material, to see more likely how the questions for your national exam are going to be. So you're going to be prepared. So that's basically what it is. Okay. If someone within this class don't like the way that I'm giving you exams and you want to have quizzes and you want to have a midterm, well, no problem. We can meet and I give you those quizzes in person. I give you a midterm and I give you the final right there. So just, send me a message, Professor, I don't like the way that you're giving your test. I wanted to have it presential. I want to really know what I'm learning and blah, 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 blah. Please let me know, okay? But that will be affecting only the one that sends me the note, not everyone else. Got it? Okay. Any questions about anything that I just discussed? Why are you guys so quiet? You guys don't want to talk to me?
Just tired.
I know, and that's the reason what I told you guys. I don't want to give you a test that, you have to answer it right there in the class. Oh my goodness,
Yes,
after a long
because
day of work,
because
fighting
when I
with your
was
coworkers, having a long, doing overtime, thinking about going home and cooking for your kid. Oh, that would be a
yes,
disaster.
when I was doing the medical billing, he'll give quizzes like after like some quizzes like after the class.
Uh-huh.
Yeah. But that's good what you say, like just one test with like everything. That's perfect.
Yeah, I mean, I want to give you the benefit, because like I said before, we're adults and busy people, this is not the only thing that we're doing. So, but yes, we want to kind of, earn that degree and probably do something better to better our lives. Come on, I'm not gonna be the one who's gonna be, the stone on your way. So I'm gonna try to kind of help you a little bit. Okay. All right. So that being said, if there is no more questions, we're done for today. And for the week, remember, tomorrow there is no class on Fridays. So we are going to meet again back on Monday. So you guys have a wonderful weekend. Relax a little bit. If you have your Saturday and your Sunday, do something for yourself. And I will be seeing you back on Monday, okay?
Okay, good night, everyone.
Good night, everyone, right
Good
now. So
night.
take
Have a good
care. Okay,
weekend.
you too.
Hi, have a good weekend, Mr. Professor.
Thank you. Likewise. Enjoy weekend.
You too.
Don't drink and drive.